In the mountains of western China, engineers buried 9,000 tons of explosives beneath the earth. Their target? Over 300 mountain peaks. But this wasn't mining. This wasn't warfare. China was about to pull off something the world said was impossible, and what happened next left global experts speechless. Nestled deep in the Sichuan province of southwestern China lies Chengdu, a region draped in emerald peaks, rolling valleys, and some of the most striking natural beauty the country has to offer. For centuries, this landscape has remained largely untouched. The mountains stand tall. The rivers wind quietly through ancient rock. It's the kind of place travel photographers dream about. But beneath this serene exterior, something extraordinary was stirring. Something that would soon challenge every assumption the world held about what's physically possible in modern engineering. Picture this: hundreds of Chinese engineers working around the clock in a remote mountainous zone. Their mission? To bury a staggering 9,000 tons of high-grade explosives deep underground. Now, if you heard that in isolation, you'd probably assume it was a mining operation, maybe a search for rare minerals, or perhaps some large-scale resource extraction project hidden from public view. But you'd be wrong. What China was planning was far more audacious, far more unprecedented. They were about to flatten over 300 mountain peaks, not to extract anything from the earth, but to build something on top of it. A massive international airport, right there, in one of the most geographically hostile regions imaginable. When the plan first leaked to the international press, reactions ranged from skepticism to outright mockery. Western media outlets published articles questioning the feasibility. Engineering forums buzzed with doubt. Critics argued it was a fantasy, a propaganda stunt. There was simply no way, they said, that anyone could reshape an entire mountain range and construct a world-class aviation hub in such a short time frame. But China has a habit of turning doubts into monuments. In less than a year, those same critics fell silent. The mountains that once dominated the skyline were gone, leveled, flattened, transformed into a vast construction platform. In their place rose the skeletal framework of runways, taxiways, and terminals. International reporters who arrived expecting to witness failure were instead greeted by one of the most impressive feats of civil engineering in modern history. But here's the question no one seemed to be asking at first. Why? Why go through the astronomical expense, the logistical nightmare, the environmental challenges, just to build an airport in such a difficult location? What was driving this? Let's rewind and understand the bigger picture. Chengdu isn't just any city. It's one of China's cultural and economic powerhouses. Positioned on the western edge of the Sichuan Basin, it borders the vast Qinghai-Tibet Plateau to the west and the Aba-Tibetan and Qiang Autonomous Prefecture to the northwest. The metropolitan area sprawls across more than 14,000 square kilometers, roughly 20 times the size of Seoul, South Korea. It's a city of contrasts, modern skyscrapers rising next to ancient tea houses, bustling tech districts adjacent to centuries-old temples. But what really put Chengdu on the global map wasn't its economy or its history. It was its food and its pandas. Sichuan cuisine, with its bold flavors and fiery spice, has become a culinary obsession worldwide. And the giant pandas, those iconic black and white ambassadors of conservation, have made Chengdu a must-visit destination for animal lovers across the planet. The numbers tell the story. In 2024 alone, Chengdu welcomed over 306 million tourists. Let that sink in. That's nearly triple the entire population of Japan, visiting one city in a single year. Among those visitors, more than 1 million were international travelers, a jump of nearly 200% compared to the previous year. But there was a problem. As Chengdu's global profile grew, so did the strain on its infrastructure. Aviation became the primary gateway for international visitors. Flights into the city multiplied, airlines added routes, tourism operators expanded packages, and suddenly the city's existing airport, Chengdu Shuangliu International Airport, started groaning under the pressure. Ticket availability during peak travel seasons became a nightmare. Flight delays stacked up. The facilities, once sufficient, were now bursting at the seams. It became clear that Shuangliu alone could no longer handle the demand. Something had to be done. After extensive studies, feasibility reports, and planning sessions, local officials made a bold decision. They would invest over $10 billion to construct an entirely new international airport. A facility so large, so advanced, it could rival the biggest aviation hubs in the world. But here's where things got complicated. Chengdu's geography is, to put it mildly, a mess. The western portions of the metro area sit on the fringe of the Sichuan Basin, dominated by deep hills and rugged mountain ranges. Elevations fluctuate wildly, anywhere from 1,000 meters to over 3,000 meters above sea level. Some peaks soar beyond 5,000 meters. It's a landscape sculpted by tectonic forces, carved by rivers, shaped over millennia into something beautiful, but utterly unsuitable for construction. The eastern region is somewhat flatter, characterized by alluvial plains, low terraces, and gentle hills. The average elevation there hovers around 750 meters. But even that terrain comes with its own issues. Soft soils, flood risks, and limited space for expansion. Finding a suitable plot of land in this topographical jigsaw puzzle was like searching for a needle in a geological haystack. The engineering team needed a site that was flat, stable, accessible, and large enough to accommodate a sprawling international airport. In Chengdu's landscape, that combination simply didn't exist naturally. But China doesn't wait for nature to cooperate. It reshapes it. The engineering team launched what can only be described as an exhaustive search. They surveyed countless locations. They ran computer simulations. They studied soil samples, drainage patterns, seismic activity, wind corridors, and airspace logistics. Every potential site was scrutinized, tested, and compared. After months of rigorous analysis, they zeroed in on a location, Lujia Town, under the jurisdiction of Jianyang City, which itself falls under Chengdu's metropolitan governance. On paper, Lujia seemed promising. The area was relatively open. There were no densely populated residential zones nearby, which meant fewer people would be displaced. Critically, the site wasn't located along any major migratory bird routes, a crucial factor in aviation safety. Bird strikes are one of the most dangerous threats to aircraft, and locating an airport away from these natural flight paths significantly reduces risk. Additionally, the airspace above Lujia was relatively clear, minimizing potential interference with existing flight corridors. And because the population density was low, the costs associated with land acquisition and relocation would be manageable. In China, compensation for relocating rural populations typically costs less than $20,000 per household, a fraction of what similar projects would cost in more densely populated areas. So the site was chosen. But choosing the location was the easy part. Now came the real challenge, making it usable. The terrain around Lujia was hilly, uneven, and broken. There were over 370 individual hills scattered across the construction zone. Some were small, others were sizable peaks. But every single one of them had to go. This is where the 9,000 tons of explosives come into play. Chinese engineers executed one of the largest controlled demolition and land leveling operations in modern history. They strategically placed charges deep within the bedrock of each targeted hill. Then, in a carefully choreographed sequence of detonations, they brought those mountains down. The scale of the operation was staggering. When the dust settled, literally, the rubble amounted to 180 million cubic meters of earth and rock. To give you a sense of that volume, imagine filling a football stadium to the brim with dirt and stone, then repeating that process hundreds of times over. But here's the genius part: they didn't haul it all away. That would have been prohibitively expensive and logistically insane. Instead, they repurposed it. Over 100 million cubic meters of that displaced material was used as backfill. Engineers transported it to nearby valleys, gorges, and depressions, filling them in and creating a vast, level platform. What was once a chaotic jumble of peaks and valleys became a flat, stable foundation suitable for constructing one of the world's most advanced airports. It was landscape architecture on a scale that defies imagination. But flattening the terrain was only the beginning. Once the site was leveled, the engineering team faced another challenge, one that no other airport in the world had ever tackled. China wanted to integrate a high-speed railway directly into the airport terminal, not adjacent to it, not underneath in a separate tunnel, but through it. The trains, traveling at 350 kilometers per hour, would pass directly beneath the main terminal building, without slowing down. Think about that for a moment. A high-speed train hurtling through a structure that simultaneously supports thousands of passengers, luggage conveyor systems, retail spaces, and boarding gates. The vibrations alone could compromise structural integrity. The noise could be unbearable, and if anything went wrong, the consequences would be catastrophic. No airport had ever attempted this. There were no blueprints to follow, no case studies to reference. The Chinese team was venturing into completely uncharted engineering territory. They assembled a task force of the nation's top structural engineers, railway experts, and architects. For years, they ran simulations, built scale models, tested materials, and refined designs. Failure wasn't an option, but neither was compromise. The railway had to work, and it had to work perfectly. After countless iterations, they developed a breakthrough, an ultra-thick gradient arch-top plate construction system. It's a mouthful, but essentially, this technology creates a reinforced structural barrier between the railway and the terminal above. It isolates vibrations, distributes weight evenly, and maintains structural stability, even as trains shoot through at breakneck speed. To further safeguard the terminal, engineers installed 694 specialized vibration-dampening units at the base of the terminal hall. These devices function like massive shock absorbers. They capture the kinetic energy generated by passing trains and dissipate it harmlessly into the foundation. The result? Passengers walking through the terminal above wouldn't even notice the trains speeding below. The terminal building itself weighs 140,000 tons. Distributing that load evenly while accounting for dynamic forces from the railway required precision engineering down to the millimeter. But they pulled it off. Construction officially began in May 2016. The project was divided into two phases with a combined budget exceeding $10 billion. The second phase is slated to begin toward the end of 2027. But here's what shocked everyone. The first phase was completed in just 5 years. In June 2021, Chengdu Tianfu International Airport officially opened to the public. The facility is honestly breathtaking. The total construction area spans 720,000 square meters, equivalent to more than 100 standard football fields laid side by side. The design itself is striking. From above, the terminal complex resembles a pair of enormous lung lobes, symbolizing both the respiratory vitality of the city and its role as a gateway connecting Chengdu to the world. The airport features 3 runways arranged in a 2 vertical, 1 horizontal configuration. This layout allows for simultaneous takeoffs and landings in multiple directions, drastically improving efficiency and flexibility. The terminals, parking facilities, air traffic control center, and aviation fuel systems are all state-of-the-art. Terminal 1 alone covers 390,000 square meters. Terminal 2 adds another 320,000. To build just the first terminal, engineers drove over 5,400 foundation piles into the earth, with a combined length of 72,000 meters. They excavated 1.6 million cubic meters of soil, roughly equivalent to building a 300-meter-tall skyscraper from a standing start. The steel reinforcement used in construction totaled over 110,000 tons. That's nearly double the amount of steel used in Beijing's iconic Bird's Nest Stadium. Currently, Tianfu Airport can handle more than 60 million passengers annually, with a cargo throughput capacity of 1.3 million tons. By 2030, those numbers are expected to skyrocket. Passenger traffic could hit 100 million per year, with cargo capacity expanding to 3.5 million tons. If those projections hold, Tianfu will rank among the busiest international airports on the planet. But Tianfu isn't China's first rodeo when it comes to building airports in impossible locations. Let's travel back to 2002, to the province of Guangxi. Guangxi is famous for its karst mountains, those otherworldly limestone peaks that look like they've been plucked from a fantasy novel. The region is a postcard of natural beauty, drawing tourists from all over the world. But beneath that beauty lies something else, vast reserves of valuable minerals. Take Hechi City, for example. Geologists have identified 46 different types of minerals scattered across 186 mining sites in the area. The region is particularly rich in non-ferrous metals. Tin reserves exceed 530,000 tons. Lead deposits reach 870,000 tons. And zinc? A staggering 7.54 million tons. But here's the problem. These resources are buried deep in mountainous terrain, far from major transportation networks. Getting them out efficiently was nearly impossible. At the same time, the region's tourism potential was being strangled by poor accessibility. Visitors wanted to come, but getting there was a logistical headache. So local officials made a decision that seemed, at the time, borderline insane. They would build an airport, not in a valley, not on flat land, but on top of a mountain. The project cost 8.5 billion yuan. The result was Hechi Jinchengjiang Airport, a 4-sea-level feeder facility designed to handle medium-sized commercial aircraft. The terminal covers 4,600 square meters. The apron spans 14,400 square meters. And the runway? It's 2,200 meters long and 45 meters wide, sufficient for aircraft like the Airbus A320 and Boeing 737. But building a runway on a mountaintop isn't just about pouring asphalt. The engineering team had to level 65 individual peaks to create a stable platform. They installed advanced instrument landing systems and radar navigation equipment, ensuring that planes could land safely even in challenging weather conditions. Since its opening, the airport has transformed the region. In 2024 alone, it generated over 40 million yuan in economic activity for the local area. Resources that were once trapped in the mountains are now flowing out. Tourists who once avoided the region are now arriving in droves. So what does all of this mean? China's ability to construct world-class infrastructure in geographically hostile environments isn't just a technical achievement, it's a strategic one. For developing nations facing similar challenges, mountainous terrain, limited flat land, underdeveloped transportation networks, China's approach offers a blueprint. And the world is taking notice. More and more countries are reaching out, seeking partnerships. They're asking China to bring its engineering teams, its technology, and its expertise to their own soil. Projects that have been shelved for decades due to perceived impossibility are now being revisited. What once seemed like science fiction is now standard procedure. So the next time someone tells you something can't be done, remember this. There's a country that buried 9,000 tons of explosives under 300 mountains, flattened them all, and built an airport that moves 100 million people a year. They ran a high-speed train through a terminal without slowing it down. They built a runway on a mountaintop where logic said nothing should exist. The impossible, it turns out, is just a challenge waiting for the right engineer. If stories like this fascinate you, if you want to see what humanity is capable of when ambition meets execution, then you're in the right place. Hit that subscribe button. Turn on notifications. Because the world is changing faster than ever, and we're here to show you how. Thanks for watching. And remember, the future isn't built by those who wait for permission. It's built by those who move mountains, literally.